trigonometry, triangles and angles. A triangle is defined as a two-dimensional plane figure bounded by three sides and containing three angles. The angle rule, which applies to all triangles, says that A plus B plus C, the three angles in the triangle, add to 180. There's also a length rule, which applies to all triangles, which states that the length of each side is shorter than the sum of the lengths of the other two sides. So for example, the length A, regardless of which one you choose as A, must be smaller than the length of the sum of the other two sides. Here's an example of a special triangle. It's called an equilateral triangle, where the three sides A, B and C are the same length. This is indicated by them having the same characteristic dash here, so indicating that they're all the same. As they're the same, the angles opposite each side are also the same, and because there are three of them and they're all the same and they have to add to 180, the three angles are each equal to 60. So A plus B plus C is 180. As for all triangles, the three angles are the same, so in this case they're all equal to 60, and that's the special triangle called the equilateral triangle. Here's an example of another special triangle where two sides A and C are the same. So here we've got the length C and the length A, and they're both the same, and we indicate that by a common dash mark. Now it's not on B, indicating that A and C are the same, but not the same as side B. The angles opposite A here, and opposite C here, are also the same as each other, so indicated by a common dash mark there. But B is not the same as either A or C. The general triangle, called scalene or oblique, is a triangle where the three sides are each different, so neither A, B nor C are the same, and they've different dash marks on them, so they're not the same. And the three angles A, B and C also have three different patterns there to indicate that they are different. And this is the general triangle. Three sides different, three angles different. It's important to note that each lettered side is opposite the same lettered angle. So once you choose A, B and C, you have to choose the angles that correspond to the opposite side of those sides. So for example here, the angle A is opposite side A, angle B opposite side B, and angle C opposite side C, and that's always the case. So once you choose your A, B and C, you must choose the angle for B opposite B, C opposite C, and A opposite A. Here's another special triangle. It's called the right angle triangle, and in this case one of the angles, we've shown it here as C, is 90 degrees. So we can see it's horizontal and vertical. So there's a perpendicular there, a 90 degree, a full bend there. The other two angles make up the rest of the 90. So you have 90 plus another 90 giving the 180. Once again, each lettered side is opposite the same lettered angle. C opposite C, B opposite B, and A opposite A. There's the 90 degree in that case. And opposite the 90 is the hypotenuse. It's the longest side in the triangle because with 90 degrees gone and another two angles to make up the 90, this must be the largest angle in the triangle. As it's the largest, this is the largest side opposite the 90 degrees, and it's called the hypotenuse. You can also describe triangles in terms of their internal angles. For example, here's a triangle with acute angles. Acute angles are angles where they are less than 90 degrees, less than the straight angle. So all three angles here are less than 90. Here's an example of a triangle with an obtuse angle where the angle C is greater than 90. It's bending back on itself. It's further than the right angle, bending back. And finally, we look now at external angles. External angles are if you have a triangle here and you extend the triangle beyond the point of the second line, you can see that that whole angle there is a straight line. So that's 180 degrees. So C plus D is 180. C plus D is 180. The D angle there is called the external angle because it's not within the triangle ABC. C plus D equals 180, but equally C plus B and A equals 180 because the three internal angles add to 180. So A plus B plus C is 180, but also C plus D is 180. Now C and D 180, A, B and C is 180. They both share C in common, so it means that D must equal A plus B. And over here we can see that D is A plus B, or this external angle here, D, is the same size as the sum of the other two. We can do the same calculation for this angle here. This is B plus E, extending the triangle beyond this point. So B plus E is 180 here. And this B plus E is 180, as is B, C and A. So whatever B is, E must be the rest to make it to 180. E must equal C plus A. So E is A plus C. So the external angle is equal to the sum of the other two internal angles.